really have expertise, I want to say, in crypto, in AI, in physical AI as well, and the intersection of those technologies. They join us from three of what I want to say the largest physical AI companies that are operating in the Web3 and blockchain space, and we're incredibly excited to have them join us here. In 2026, you're increasingly hearing the phrase that the ChatGPT moment for robotics is right around the corner. I think a lot of people are saying it. It could be due to a combination of accelerating venture funding within the physical AI space more broadly. It could be due to early signs of scale of deployment, where you're seeing maybe Sunday Robotics, 1K, responsible for household robots actually being shipped at the end of this year. Tesla's Optimus is potentially projected to be shipped in Q3 or Q4 of this year as well. And at the same time, you're seeing the rapid advancements of intelligence from a software AI level. And this is really accelerating that pace of discussion around physical AI. So Amanda is the COO of BitRobot, where they're building the world's open robotics lab. Paige joins us from the Fabric Foundation, serving as the executive director. Among the foundation's early contributions is OpenMind, a Silicon Valley-based startup building essentially operating systems for both humanoids and I'm going to try pronounce this type of robotic device, but it's called quadreps. And Paige, feel free, correct me if I'm wrong.
Just robotic dogs.
Robotic dogs, as simple as that.
Legs.
As simple as that, but the wording makes it slightly too complicated. And then we have Bayley here, our own Bayley, who actually brought in humanoid devices and physical AI devices and showcased them during our product demo as well. So thank you all three for joining us. And Bayley is the co-founder of PrismaX. Now I happen to be moderating, but I also lead Decasonic's AI investments into physical AI more specifically, and leading our internal AI product development as discussed prior. We're going to kick it off straight with questions. AI continues to accelerate, and 2026 is shaping to be a pivotal year for physical AI. Alongside what I mentioned about some of the contributing factors, what's the reason why physical AI is actively being discussed much more aggressively this year?
Yeah, I guess I'll go first. I've been in, I guess before the industry was called physical AI, it was just called robotics. And I think the most interesting thing is people are seeing a lot of excitement that the hardware problem has finally been more or less solved. I'm actually going to backpedal on this a bit versus a couple months ago, as we've been putting more and more hours on our machines. We've discovered that little things like, connector reliability, wiring harnesses are still, people are still working on them. But by and large, the hardware is no longer a research project, and that's super important because it makes physical AI investable as a venture funded model, right? So funding people to do these large-scale manufacturing, large-scale hardware development is really hard. A lot of the money winds up being CapEx. You need years before you can ship a product, and you really don't know whether you have PMF until you've shipped. Now that the hardware is available off the shelf, we can execute in a very agile, work on the software, work on data, work on AI models, and that makes the whole field a lot more interesting for VCs, for investors, for startup founders. Besides that, I think the other reason is, of course, the technical one, that last year in 2025, companies like Physical Intelligence showed that end-to-end machine learning was suitable for physical AI. You could build a model which directly took vision and learned how the physical actions from that robot were. And that's important because it's easy to scale machine learning. You can scale it by putting capital into fleets and data, train better models, right? It's a capital problem. We know how to do it. We know how to scale, versus the old rules-based approaches where you would have your team write these rules, write these scripts over and over again, but the machine was never reliable, and at the end you went out of business, never quite knowing why. That the thing that worked great in the lab when you shipped it to the customer slapped the user 7% of the time, and that's not a very good feature to have. So I think the combination of these two things is really driving a lot of confidence in physical AI as a viable business, as something which you can invest in, as something which is worth building in, and that's making the industry really take off.
From my perspective, I think it's when people start to realize this has transformed from a tech problem to a financial assets problem. I think right now we are almost at the age of 2022, like ChatGPT 3, ChatGPT 2.5 age, when situational awareness was still in incubation time. People start to realize, right now if you start to invest in data center today, it's already late, and people start to see, okay, there's CME start to have data center perp, but that they've been doing that for 2 years. They're just announcing it recently. For robots as well, so we started out in early 2024. That was when physical intelligence was raising its first round, and Figure was still under $1 billion valuation. But this year, people start to realize, hey, these companies are starting to triple or their valuation, and the recent stock market swing on the AI related assets, people think maybe the next wave is on robots. So it has really exited the research small circle in the Bay Area and start to get more attention from the Wall Street. So that's my bet. And you see Agility also is filing their SPAC with Foxconn as the main sponsor. So we see more and more this intersection between the financial world and the tech world in the Silicon Valley start to converge. And we see this more and more. Since the beginning this year, you have more data companies raising a lot of money, and they are coming out of stealth, but they've been building that for 2 years. We see a lot more companies going to the public space probably later this year or beginning next year when Elon launching Optimus.
Appreciate that. And Amanda?
So I would, second everything they've said. I think the other factor we've seen is just the success of Anthropic and OpenAI as major AI labs. And then also the success of Waymo and Tesla in the self-driving space. And so I think then it's clear that the next direction is in the physical world. And so that's around general purpose robots, general purpose robotics models, and then also more vertical specific, building the best robot software stack across different types of verticals where there's labor shortages, especially.
So generally speaking, I think we seem to be in agreement. 2026 is the year that we're seeing accelerated capital being deployed into the space. We're seeing intelligence, and at the same time, we're seeing the contribution of the actual deployment of robotics and autonomous devices, whether or not they're Waymos, humanoids, robot dogs, and whatever form factors these robots essentially come with. I think two of our panelists here are very focused on data, right? We have PrismaX primarily operating from a teleoperation perspective, and we have BitRobot as well, both on the teleoperation side of things and also egocentric data with a cap as well that's essentially available for labs to utilize. There's also different types of data. We're seeing synthetic data, we're seeing world model generated data, and I'm sure there's going to be a ton of different form factor of data that we're going to start seeing. What type of data collections are both of you actively using, and where do you see the trajectory of the data market in physical AI heading towards? Is it continuing to be the bottleneck when it comes to adoption and actual deployment of devices?
We'll go in reverse this time. Amanda can go first.
Yeah, so there are 3 types of data being used by robotics researchers. So one is teleoperation, as you mentioned. So this is essentially piloting a robot to teach it to do various tasks. So it requires one person and one robot, and it's the most clear way to translate robot, data to a model. And then the growing areas that are more scalable would be simulation. So the issue with simulation data, though, is that there's a sim to real gap, especially around tasks that are more dexterous. And then the third is egocentric video. So this is basically using video captured from humans to train robots. I would say we're focused on all 3, but where we've seen the biggest opportunity and change actually over the last year is the emphasis on human data. And so if you think about how do you get millions, hundreds of millions of hours, having one person operate a robot all day is not the most scalable. And so we've seen that in pre-training, labs have had success. There's published results from NVIDIA, Skilled, Figure, using human data and then translating that to train a robot. And so I think that's been a big recent trend where before the focus was primarily just teleoperation.
So I guess speaking a little bit from the point of view of the data buyers, we see the most commercial activities surrounding teleoperated data right now. Because if you're paying for data, you're probably not interested in taking a risk on this expensive data. You probably want to be able to go back to your boss and say the millions of dollars we're spending on data is translating into models. And it's a proven method that teleoperated data does work. Egocentric data is a bit more frontiery, I would say. There have been some results saying that ego is valuable. We're seeing some demand for ego. But by and large, the issue with ego right now is that there are no end-to-end documented results primarily training on ego and achieving performance which exceeds that of the teleoperated models. You can make an argument that it's more scalable or it costs less, but there isn't really a strong argument that the performance is outright better. And I think that's what's scaring a lot of people away. Right now, if you put yourself in the shoes of a customer who's building foundation models, it is an exceedingly competitive space right now. We've gone from these 3 big shops to, I don't know, 10, 20 people who are all building some variant of world models, end-to-end integrated solutions, right? So you do need to be able to show results to your shareholders and hopefully your customers as quickly as possible. I think from a technical point of view, it's just, I don't see that there's a particularly strong distinction between the two. Both are primarily video modality trained on some action, which is either explicit robot actions or some implicit action extracted from the videos. And ego is nice because you get a lot more diversity. You can access people who don't access to robots but have access to interesting environments. Teleoperated data is just inherently more methodical because you're paying a lot of money to collect it, so you're probably putting a lot of thought into it. In the end, it's going to be just a magic soup. I don't think any one is going to win or the other. The announcements you see right now are basically like fundraising narrative type announcements, where if you're like generalist and you're trying to raise, they're going to ask you, why are you better than the competitors? And you're going to go spout this thing about how you're trained on half a million hours of ego video. But realistically, internally, it's whatever data you can get your hands on right now. There just isn't enough good data. So if the data is available, you are going to figure out how to use it.
And Bayley, we're gonna stick with you and PrismaX here for a second. I think what we're seeing in software AI and physical AI is software AI had a lot of training data, primarily because it's trained on the internet, right?
Correct.
And you were able to be very selective when it comes to scraping data, providing certain sites, maybe removing elements that you don't want a LLM or an AI system to essentially provide you with an answer for. But you can't have that level of affordance with physical AI. And the result of that is that you want to scale data as much as you can, as quickly as you can, and therefore the quality of the data that you might be able to gather might be a little worse than you might expect it to be, generally speaking. What's the general approach when it comes to data quality that you're seeing, and specifically, what is PrismaX doing to address that?
So I actually think that physical AI companies this year are moving more and more towards maximizing the amount of high-quality data in the training split. Last year was sort of a get where we can as quickly as possible, so you would grab data sets off Hugging Face, YouTube, and try to make it work. This year, people are more serious about actually going after a use case, and if you think about it, the data you buy or the data you pay to collect is yours forever. It's an investment which probably goes into every model you ever train. Given that you're paying humans to collect this data anyway, it doesn't really make sense to pay a little less to get like a worse asset that is yours forever and is like an investment in the entire future of every model your company will ever train. So the emphasis really is on, even for ego video, reducing the amount of slop in the data sets, even if it means paying more or going a bit slower. I think people have realized this year that trying to hit like a billion hours as quickly as possible was last year's storytelling, but it's not as practical as you think it is, right? If you think about it, the training pipelines aren't ready for that much data. How do we scale the models to not overfit or underfit on that data? There's a lot of unknowns. The model has to run in real time. So it looks a bit like language model post-training, I would say. If you think about it, something like Claude or GPT 5.6 isn't really trained on the internet anymore. It's trained on billions of dollars of data which human experts have generated. And that's the magic which makes these frontier models good. The internet backbone has gotten worse over the past 3 years because it's now full of AI slop as well. But while that data is what enriches the models, really the high quality data is what differentiates the models and makes them commercially very viable. It's the difference between like a chatbot which outputs slop and something which replaces a team of engineers.
And one way to get expertise is really to have that economic coordination layer that enables participation. And we at Decasonic primarily believe that the intersection of Web3 and physical AI will primarily play a role within that economic coordination as well, whether it's resource contribution, resource ownership, or potentially even the trajectory or possibilities of machine identities coming on-chain, and maybe even machine-to-machine payments in the near future. For each one of you, what's the role that crypto plays with AI, and where do you think, physical AI more specifically, and where do you think that role is headed towards as well?
Yeah, so we probably have like a different approach here compared to the more data-focused protocols. For us, crypto is mainly acting as a financial primitive for robots. To us, robots are just new economic actors in the world where they can't really create a wallet, they can't create a bank account, and then they can't really transact with each other and with other AI agents and human beings. So the main product we have is a Robo-Financing and Robo-Pay. The reason we're doing that was because we started out from being like a distributor for most of the biggest OEMs in the world, and as a distributor, easily you can get like certain profits just from distributing the robots to the buyers. And during this process, we realized there are certain time lags in between the buyers. They need to have like T plus 30 or T plus 45, whereas the OEMs, they need to have the full amount paid before they ship out the product. And this is like a classic problem in supply chain financing, but we think this is a huge opportunity in robotics world today that the industry hasn't really caught up. It's like data center many years ago when people only thought of it as like a real estate financing problem, but accumulatively, we are able to accumulate assets as robots, and we're able to enable value creation among these assets and between the assets and the external world. So for Robo-Financing, we closed a deal a few months ago with one of the biggest car manufacturers in the US, and able to have pretty lucrative, like 15 to 20% APY. And we're closing another deal with the top e-commerce platform here. So all of them, they're purchasing a lot of robots, especially robot dogs, because they're really functional today compared to humanoids from overseas OEMs. And this, entails overseas transaction, underwriting, and quick cash upfront, and also able to track the performance, also the utility and the value generated by robots afterwards. So all this value chain is what we are trying to capture in Fabric. So to answer your question, I think crypto itself is like a really convenient and already easy to use tool today for us to really tap into this market as a first player. And the other thing we're working on is agentic payments between robots. So we are adopting the AI software like X402 payments, So X402 basically, it's like a per API call micro payments that enabled by USDC, USDT, these are stable coins. And last year in December, we launched a protocol with Circle that we enabled the first autonomous charging by a robodog in Silicon Valley. And this will only expand as we integrate our protocol with more robot form factors and with more stablecoin players in the field. Today, there's no such a transaction existing because there's no robots like roaming around us. But we already see a lot of micropayments by autonomous AI agents online. That's unthinkable a year ago. So as we see robotics start to scale more and more, when we start to see Optimus 1X Sunday robots start to ship their robots in humans' houses, it's not unthinkable to say, hey, like I want a robot in New York to do certain things for me, whereas I'm physically in San Francisco. And we believe that this payment rail will be enabled by crypto, and that's what we're building.
I mean, it's fascinating when you consider just potentially the similarities that we see from a software LLM perspective, software AI agents to robotics and physical AI more broadly. I think we started out with singular AI agents, single LLM systems, and now it's about orchestration, both from an agentic perspective and even subgroups of AI agents being able to orchestrate each other. And there's one question that's always on my mind, and this is a personal conversation that I often have with maybe some experts that operate in the physical AI space. And I'll throw this to both you, Bayley, and Amanda as well, BitRobot, PrismaX. What is the orchestration of physical AI? And primarily, are we going to see a fleet of potential physical AI devices, either humanoids, either robotic dogs, operate in the near future?
So this question is easier to answer now than it was 6 months ago because we now have functioning fleets of software agents. And in my eyes, the first production physical AI systems will sort of behave like, Claude Code, but with a bonus physical like subtool, and the tool can be commanded to do very simple things. Like, I'm already poking around, experimenting with this idea of connecting Claude Code to like a physical machine, using it to evaluate its feedback and sort of orchestrate these longer repetitive tasks. I think that simplifies the burden you have to place on the end-to-end part, right? It can be a smaller model that maybe can only do a few tasks, like turn this screwdriver, press this button, but it's still really useful because right now, if you let your software tooling like run autonomously, you still need a person to go like push the buttons if you have to interact with the physical world. And I see a lot of value in that in things like R&D scenarios, labs, biology, right? Like all these things where you just have to pay an expensive guy to push the button can now be replaced by a robot. It's nice and simple, and a lot of those are they're multi-robot jobs. They're naturally more multi-robot to increase throughput. You can run more tests. So I think that's a very practical application. Beyond that, there's a whole orthogonal world which deals with fleet management. It's not something we deal with, but the idea is for very large production fleets of robots. We're talking more forklift-type machines where there might already be some commercial deployments. Managing this health of those machines is challenging. If you have 1,000 units deployed, one of them will probably fail a day. Like, that's pretty good. That's 3 nines of uptime. You need to go like locate the dead robot, figure out what's wrong with it, and put it back in the fleet. And it is very challenging. I draw parallels to managing your data center full of GPUs, where on average, I don't know whether anyone here has ever trained a foundation model, but if you have 1,000 GPUs, roughly speaking, one node of them goes offline a day, and it is absolutely a pain in the ass to go find the bad node and bring it back online. So we've gotten more and more sophisticated tools to deal with the fleet management. There used to be, you had like a grad student watch the nodes and go unplug the one that went down. There's the same problem for physical AI, right? Like there's a lot of fleet management, et cetera, et cetera. But that's sort of orthogonal to, I guess, current physical AI trends. Those are more traditional automation type tasks.
No, it does remind me when I used to mine Ethereum, I think Bitcoin as well, some related hardware issues over there
you know,
too.
you have your dusty Ethereum mine, and every day one of the nodes goes down, so you have to keep the uptime high to keep the revenue going.
That is indeed what was happening with me a few years back. And now we'll leave it off with Amanda from BitRobot as well.
So one trend that I've seen in deployments and trying to get robots in the field sooner is actually to incorporate teleoperation. So 1X announced that they're going to be putting robots in people's homes, and there's actually going to be a teleoperator involved. I think that's because in the homes, like every home looks a little bit different. The setup is different. Even doing at the task, the lighting is different. So there's too many components for a robot to reliably do it. But it's also not like, you know, a death sentence, let's say, if the robot messes up folding your laundry. And so the homes are a good place to test robots and continue to collect data and train them using teleoperation. Whereas I think in the more industrial developments, like Bayley was saying, it's a bit more like, okay, if you must correctly like package this good, and you must continue to do that. I think Figure was doing that for 7 days with their robot, but again, maybe not in a different environment. I don't know the conditions of what they were filming under, but I think that's kind of the two angles: either master industrial tasks really well, and then that's how you get robots in the field, or put them in a setting where it's okay if they mess up and teleoperate them.
Brian, do we have any time for potential questions? One question. Do we have any question for any of the panelists here? Nitsa?
Yeah, probably for Bayley and Amanda. Do you have any standards when you're collecting your data that guarantees down the line better embeddings? Like, is there anything specific, or are there even like different types of data that you're collecting just to guarantee high quality embeddings down the line?
The short answer is yes. We have a lot of standards and requirements we apply to every modality we collect, from the devices they're collected on, the robots they're collected on, to basic technical things like obviously like frame rate jitter, all the way to more holistic things like the smoothness and diversity and value of the trajectory that all go into building a good model. I think that's what makes a good data supplier. Good data suppliers need to think about how the models are working and learn to build data tool stacks and data pipelines which allow them to really help the robots learn. I think this is something that went wrong with the first generation data companies. Their metric was simply number of hours of teleoperated data collected. So you see these huge Chinese data factories that can output 1,000 hours a day of data, but it's all the same data. It's like 1,000 hours of a rice cooker being loaded over and over again, and that wasn't even a useful problem in the first place. Or they'll like give you mock manufacturing data, but it's in a clean white background and it's just like a robot plugging in a cable. You need more richness than that. Like sure, it's good to have 100, 500 hours of simple stuff, but beyond that, you really do need to scale up the complexity of the tasks, because the goal in the end is to build a robot which can be useful in the real world, and that's not happening through 15-second snippets of pick and place data. That's happening through rich design tasks, good annotations, et cetera, et cetera.
Yep. So beyond the just like meeting the requirements and the standards, I think it's also diversity of environment. And so especially in the learning from human data, the goal is to capture any type of economically valuable labor and to do it in as many diverse settings, tasks, and everywhere around the world. So I think that's what we've seen as like kind of the most important piece of that is just like how diverse it is. You can imagine it's because you want the robot to be able to operate all over the world doing all types of tasks. And if you train it, like kind of Bayley was saying, on just how to use a rice cooker, I don't know, or do simple pick and place, it's really not going to get you anywhere. So that's something that we've seen is actually the most important criteria once you just meet the basic specs.
Thank you so much for the panelists, obviously, for flying into Chicago. And yeah, they can definitely answer questions after. Thank you, guys.